Welcome back to the 131st Kentucky DNA Derby with Riley Holmes and Paige Hoger.
If you're new here, we will explain the concepts.
First up, staying loose. The competition both started with a strand of DNA that is in the helix shape. Then the topomerase will loosen the two sides of DNA.
When it's time for the saddle up, the helicase will untwist the two sides away from each other. The next step is from the single-strand binding proteins, which will stabilize the DNA during the replication, preparing the competitors for their race.
Now the race finally starts. On the first turn, the lagging strand uses the polymerase enzyme to replicate the DNA by adding complementary bases such as cytosine, guanine, adenine, and thymine. It's almost as if these two strands were born to race.
The two strands are trying to get to the endpoint while pushing limits and breaking records, but the lagging strand has a different technique. Fresh out of the starting gate, it uses the polymerase enzyme to create short segments of RNA called Okazaki fragments at the replication point. These will synthesize through the ligase enzyme on the backstretch and then go through the polymerase enzyme. The polymerase enzyme adds nucleotides in a 5-to-3 direction. Though victory is the goal, speed is the means. We will see the lagging strand technique later in the official race video.
After they make it down the home stretch, it's a photo finish, and before we even know it, the race is over. The two strands twist back into the helix shape to celebrate the end of the race with good sportsmanship. Now, let's watch the official race video.
You can see the lagging strand towards the top because it is being formed in a chunk-like state and is curved.
You can also see the leading strand being formed in a smooth, linear state.
This is a really close race.
I know, the strands are going to tie!
Well, folks, that was such an exciting race. That is all for tonight. I hope you can all recover from the excitement. See you next year at the 132nd Kentucky DNA Derby.